Hi there guys, welcome to another video in this playlist looking at 10 of the key topics that we need to secure for our grade C in our EdXL GCSE exam this summer. We're looking at this one, if we look down the list here, at stem and leaf diagrams. So let's take a look at a couple of past paper questions, kind of cover some of the key facts to do with this topic. So hopefully you'll get some simple marks picked up for you this summer as we move towards that grade C. So here we go. Here are the times in minutes taken to change some tyres. So we've got some jumbled up times here, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I've got 20 pieces of data. And the reason I've counted that is not just because I like numbers and counting, but that's going to be really useful later on for me to check. Now, the format for a stem and leaf, and sometimes these are already drawn out for you in the exam, sometimes they're not, so let's pretend that we're going to have to do all the hard work ourselves, is we've got two parts to it. This side is known as the stem, a bit like a plant I suppose, and then the leaves grow off of it. So the first thing we need to do is we need to look at our set of data and we need to decide the range. We need to decide the smallest numbers and the biggest numbers so we know which stems we're going to have. So I have numbers here in single digits, so I have numbers in the units, then I've got numbers in the tens, I've got numbers in the 20s, I've got numbers in the 30s, and that's it. So I'm going to have a stem starting at 0 because that's going to be my numbers that are less than 10. Then I've got numbers beginning with 1, so in the tens, numbers beginning with 2, so in the 20s, numbers beginning with 3, so in the 30s. And then it's a case of just being really careful and meticulous and working through systematically these numbers, trying to cross them out one at a time. So let's start and look for our smallest number, which here is the 5. So 0, 5 means 5. Now I'm going to find my next smallest number, which is this 7. So 0 and 7 make 7. Then I've got this 8 and I've got another 8, so I need to put them both down. I don't just put it down once. And just double checking, there's no other single digit numbers, so those are my 4 numbers that appear in the first row for numbers less than 10. Now I need to look for the numbers that all start with a 1, and I need to start with the smallest one. So I've got a 10, 2 15s, a 12, another 10, another 10, another 10, there's a 15 there and there's a 16 there. So let's start with the 10. So 1 and 0 makes 10. Now there was another one there, so I'm going to put another one in. There's another one there, so I'm going to put another one in. And there's another one there, so I'm going to put another one in. So I've got my 4 10s. There's a couple of 15s, a 12, a 15 and a 6. So the 12 comes next. Then the 15. Then the other 15. Then the other 15, then there was the 16, and let's double check there's no other ones beginning with a 1 there. So I move into my 20s, I've got 20 there, 25, oh there's another 20 there and another one there, 24, we had that 25 that we just spoke about a moment ago. Got a 33 there, a 35 there, 33, 35, and I should be finished. So there's 2 things to check for here. 1, have I crossed off all the numbers? Well, it looks like it. 2, really useful advice here that people don't often do, but that's why they drop silly marks, is to check that this side, the leaves, I've got my 20, hence why I counted that at the beginning. I've got my 20 pieces of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So what you've just constructed there is what's called an ordered stem and leaf. It starts with the smallest number and it orders its way up to the biggest number. And usually it says in the exam, draw an ordered stem and leaf diagram. So that's what we've done there. Now before I even look at the questions, there's one other thing that's absolutely vital that sometimes people miss. Sometimes they're really helpful in the exam and they give you a bit of a warning sign for it, sometimes they don't at all. Stem and leaf diagrams always need to have a key. And what the key does is it represents and shows the size and the scale of the value. So if these no longer existed, what are these numbers in the table? So what we would say is that the 2, when attached to the 0, and before you're sat there watching this video going, well, why did he pick the 2 and the 0? You can pick any numbers you want. You could even pick numbers that aren't in your stem and leaf diagram. What you're saying to the examiner or to anyone else that's looking at this data is that the number on the stem, when attached to the number on the leaf, creates this size number. Okay, so it's not a decimal number, it's not a number in the hundreds. This is what it means. And that would be our perfect answer, usually 3 or 4 marks for constructing a stem and leaf diagram. What they then do is they tend to offer like a part A or a part B, and they ask you to do something with it. And the first one we've got here is calculate the median. Median from averages means middle number, but it means middle number once they're in size order, and that's the good news with an ordered stem and leaf diagram. They're already in size order. So I just need to find the number that's in the middle. So I've got 20 pieces of data, so that means I'm going to have 10 on one side and 10 on the other. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's check there's 10 on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is here. So between these two numbers, and here's another really big warning for you, which I see a number of students make every year. This isn't between 5 and 5, because these 5s, remember, are attached to a stem. This is between 15 and 15. So obviously between 15 and 15 is still 15. Range, for part B here, is the difference between the biggest value, which in our set of data is the number at the very end, which is 35, not just 5, remember. So 35, and the smallest value, which is the number at the very beginning of our stem and leaf, so 0, 5. So I have a range of 30, so a range of 30 minutes for these tyres to be changed. And then finally, how many times did it take less than 20 minutes to change a tyre? Well, let's find 20 minutes. Well, there's 20 minutes, as so is there and so is there. So here's 20, here's our cut-off for 20. So all of these tyres here got changed in less than 20 minutes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You could have actually found that information from the raw data above, but now we've put it in an organised way in the stem and leaf, it's easier just to count them from there. Okay, so that's stem and leaf in a nutshell. We do have another question underneath, but I'm not going to go through constructing this all from scratch because I think it's relatively straightforward from the one above. The only thing I would say here is if we look at this data's decimals. So it says the following are times for 15 athletes to run the 100 metres, and we've got the data in decimals. All I would say, and I'm not going to finish this one off like I just said, we construct our stem and leaf as usual. So stem on the left, leaves on the right. It's going to be ordered. I start by looking at my smallest numbers, which begin with a 9. So the 9 goes as the stem, and let's just quickly find our smallest number on here. I think it's 9.8. So I've got the 9 and the 8. Then in a minute I'll have the numbers in the 10 point somethings, 11 point somethings, and so on. The reason why I'm just mentioning this one quickly, the only place in a stem and leaf diagram where you would know the data is decimalised is in the key. So my 9 and my 8 equal 9.8, not 98. Do not ever put the decimal point in the stem and leaf. So I see students put it here every year. You don't need to do that. Put it between the numbers. So maybe like on the next one I put 0.9, 0.9. Don't do that either. The only point where you would see in the diagram that to know that this was decimal data is in the key here.